PreAP PreCalculus Notes Section 1.4 Interpreting Graphs of Functions, Part 2. Comparing two functions to each other. Which variable, x or y, do the function notations f and g represent? Well, they represent y. Both of them represent y. If f equals g, what must be graphically true? If f of x equals g of x, then their graphs intersect. If f of x is greater than g of x, what must be graphically true? If f of x is bigger than g of x, then f of x is above g of x. If f of x is less than g of x, what must be true graphically? If f is less than g, then f of x is below g of x. Hopefully, when you look at these things, you think these are no-duh statements. But there is some duh out there, otherwise we wouldn't have to talk about it. G and f can only be compared on the interval from -4 to 7. That would be -4 non-inclusive to 7 inclusive, because that is the interval on which both graphs exist simultaneously. Looking at these graphs right down here, sure, the solid graph, which is G, let me label this. Solid one is G, unsolid one is F. Function G exists from -5 all the way to -7. But function F exists right after -4 and also stops at +7. So that's why we can only compare these on the intervals in which they both exist. This is the only shared interval in which they both exist. On the graphs below, f of x is the dashed, g is the solid. Use a marker, highlighter, or colored pencil to trace the graph from left to right for any values on the intervals in which they're equal. F is bigger than g, or f is less than g. So the first one here, f and g of x are equal. Well, they are equal whenever the two graphs touch each other. They touch each other there, and they touch each other there. There's no other place where they intersect. Identify the x values for the highlighted portion of the graph. Well, that would be x equals -2 and x equals 5. When is f bigger than g of x? When is it higher? Let's highlight that. F is higher through here, and it's higher over here. Please note that it is not, we do not use this endpoint here because that is an open circle, it's a non-inclusive. So that first interval goes from -4 to -2, non-inclusive. And then goes from 5 to 7. 5 not inclusive, but 7 is inclusive. 7 is inclusive because it's a solid dot that's clearly above. 5 is not included because they're equal. -2 is not included because they're equal. -4 is not included because it's an open circle. When is f below g? Well, it is below right after they intersect, up until the fact that they intersect again. So that's from -2 to 5. Now, this appears to be an ordered pair, and it isn't. This is an interval. I'm just going to make sure this is clear. That is an interval. Again, we've asked this question 3 times previously. Should your intervals identified above be identified as closed intervals, brackets, or open intervals, which are parentheses? Give a reason for your choice. The intervals can be a mixture of open and closed depending on the behavior of the endpoint. Identify the domain of the graph function of f of x. F of x domain goes just to the right of -4 and stops when it gets to 7. It's a hard stop. -4 to 7. -4 not inclusive, 7 inclusive. What is the range for g? It goes from -5 to 7, both inclusive. What are the range of f? Range of f goes as low as -2 and goes as high as 6, both inclusive. The range for g goes as low as -4 and as high as +4, both inclusive because they're solid dots. F is the dashed graph, G is the solid graph. I'm just going to label those once again, F and G. For each indicated quantity, write in words what you're asked to find, then find the indicated values using the graphs. All right, first one. The value of x when f of x is 0. First of all, what does that mean? If f of x equals 0, then the graph of f of x is on the x-axis. And when is this graph on the x-axis? It's on the x-axis here at 1. And then if you continue this here, we're going to find that it's also on there at 15, and I will go over that here in a second. This slope here is 1/2. It's the same graph we had on the previous notes. So here we are at 11, -2. We go up 1 to the right 2, we're at 13, -1. Up 1 to the right 2, we're going to be at 15, 0. So that's how we know that's 15. The values of x such that g of x is equal to 0. Well, similarly, if g of x is equal to 0, then the graph of g of x is on the x-axis. So on the x-axis here, what appears to be -4.5, here at 6, and here at what appears to be 10.5. Now we could figure out that that's exactly -4.5 by using this slope. This slope here is up 1, 2, 3, 4, and to the right 1, 2, 3. So it's up 4 and to the right 3. We could calculate this for sure. And similarly here, we could calculate that for sure. The values of x such that f of x equals g of x, that's when these intersect each other. If f of x equals g of x, then the graphs of f and g of x intersect. They intersect here. It's definitely going to be an estimate. They intersect here. That one's not going to be an estimate. This one looks like it could be around -1/4. This one looks like it's going to be at 9. The value of x such that f of x is below g of x. It's less than g of x. If f is less than g, then f of x is below the graph of g of x. And that is happening all through here. Skips over this point and then through here again. So we're saying it goes from -1/4, not inclusive, to 9, skips over 9, and then goes to 11. We stop at 11. Even though this graph continues, function g stops at 11. We can no longer compare them after that. At 11, there is a closed dot. So this we would include non-inclusive, 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 inclusive. 1/4 isn't, -1/4 isn't included because that's the point of intersection. 9 isn't included because that's a point of intersection. 11's included, it's not a point of intersection, it's the end point, which is a closed point. The values of x such that f of x is greater than. So when is f higher than? It's higher than all through here, not including this endpoint and not including the point of intersection. If f is bigger than g, then f of x is above the graph of g of x. It's happening from -9, not inclusive, to -1/4. The values of x such that f of x is bigger than 0. When is this graph above the x-axis? It's above the x-axis all through here. That's -9 to 1, not inclusive. And then it's again over here when it gets past the x-axis because it goes up forever, which is going to be 15 to infinity. And what does this mean once again? If f is bigger than 0, then the graph of f of x is above the x-axis. the value of x such that g of x is increasing. If g of x is increasing, then f of x is rising from left to right. G of x is rising from left to right after -6 until it gets to 3, not inclusive, and then again from 9 to 11. All of those are non-inclusive. The value of g of x when it's decreasing. If g of x is decreasing, then g of x is falling from left to right. The only time it falls is from here, 3, to here, 9, both not inclusive. The value of x is that g of x is constant. So what does that mean? If g of x is constant, then the graph of g of x is horizontal. It's horizontal from -11, inclusive, to -6, not inclusive. You know what? I take that back. Not inclusive here at -11, because we have to be able to compare things to the left and to the right to see if it's horizontal. To the left, we can't compare, so it's non-inclusive for the horizontalness. That says -11 to 6, but it should say -11 to -6. Typo. All right, same graph. This is F, this is G. We got more questions. The value of x such that f of x is increasing. I didn't write down what this means. Blarg. If f of x is increasing, the graph of f of x is rising. From left to right. So g of x is rising starting here at just to the right of 3, and it goes for the right forever. So it's 3 to infinity. F of x is decreasing. Let me just copy this. F of x is decreasing. Then the graph of f of x is falling, not rising, from left to right. So f of x is falling right after -9 to -6. And then it falls again from yeah, that's right, from -1 down here to +3. The values of f of x that f of x is constant. If f of x is constant, then the graph of f of x is horizontal. And it is horizontal from -6 to -1, not inclusive. All right. The values of x such that f of x is less than 0. If f of x is less than 0, then the graph of f of x is below the x-axis. It's below the x-axis from right after 1, and then until it gets to the x-intercept, which we said was 15. So that's a 1 to 15, both not inclusive. The values of x such that f of x times g of x is less than 0. If you have a product that's less than 0, it means it's negative. If you're multiplying two things and the product is negative, that means that one of those has to be a positive number and one has to be negative. So in this context, it means if f times g is less than 0, the graphs of f and g are on opposite sides of the x-axis. So when are they on opposite sides of the x-axis? Well, they're on opposite sides here, which would be from -9 to -4.5. And then they're on the same side, and then here they're on opposite sides from 1 to 6, non-inclusive. And then they're on opposite sides just right here, which is about 10.5 to 11. Last one for this graph, f of x times g of x is bigger than 0. That means that if you multiply them, it's positive. That happens if you have the same signs. So if f of x times g of x is bigger than 0, the graphs of f and g are on the same side of the x-axis. So both on top or both on the bottom. They're both on top, let's see, right here. Actually, all the way to here, which would be about -4.5 to 1, not inclusive. And then they're both below right after 6 until we get to about 10.5. All right, next page. Identify the equation of h of x. This is a piecewise function. This is going to take some work. How many pieces are there, first of all? We have what appears to be linear, what appears to be a square root, and what appears to be a parabola. So I'm going to say there are 3 parts. So h of x equals, I'm going to have 3 parts to this. This first part is going to be a line. Second part is going to be a square root. And the third one is going to be a parabola. So for this line, what's the domain? It goes from -6 to -3. It's not included at -3. Then we got to figure out what the equation is for this. Well, the slope is clearly 2. It's up 2 and to the right 1. Now we could just continue to count spaces. Up 2 and to the right 1, up 2 and to the right 1, up 2 and to the right 1 to see that the y-intercept is 7. There's no shame in that. So 2x plus 7, y-intercept, slope. You could also use point slope form. It takes more work, but that's going to give you a more accurate answer, and I can show you that if you'd like. As far as this fellow here goes, its domain goes from -3 to 1. It includes 1, doesn't include -3. And it looks like to me the vertex of this little fella is at -3, 1. So I'm just going to write some stuff up here. If it's at -3, 1, it's going to be x plus 3. And we're going to have positive 1 on the outside. Translate left 3, translate up 1. Left 3, up 1. Looks like this opens down where it normally opens up. A vertical reflection, put a negative on the outside. Has the scale changed? Well, if we go to the right 1, the square root of 1 is 1. That works. Go to the right 4, 1, 2, 3, 4. Square root of 4 is 2. That works. The scale hasn't changed. So this is negative square root of x plus 3 plus 1. So over here is the domain. Put some commas after this. This is a parabola. Whereas the vertex, it's at 3, 5. So that means I'm going to have x minus 3 quantity squared plus 5. Translate right, translate right 3 and up 5. That checks out. This opens down as a vertical reflection. Has the scale changed? If you go to the right 1, 1 squared is 1. That works out. Go to the right 2, 2 squared is 4. That works out. The scale hasn't changed. So this is negative times the difference of x and 3 squared plus 5. Domain for this is 1 not inclusive to 5 inclusive. Identify the domain of h of x. Well, it goes from negative 6 to negative 3 and skips over it. Then it goes to 1, it includes it, and then it goes to the right of 1 to 5. So essentially it goes from negative 3 to 5. Let's look at the picture and confirm that. It goes from negative 6 to negative 3. There's a hole there, so we skip over it. From negative 3 to 1, 1's included here but not here, which is fine, which means we have all x values accounted for until we get to 5. What's the range of this? Let's look at our graph. It goes from negative 5 up to 1. It appears to skip over 1, but if you look here, 1's actually included here, so it doesn't skip over 1. It goes from negative 5 up to positive 5. Both included. If p of x equals this, identify the values of x for which p of x equal to h of x and explain your reasoning. Well, let's graph this. Let's graph this and then we'll determine. This is an absolute value function. It opens down instead of up. Scale hasn't changed, so the slopes are still 1 and negative 1. We're going left 1 and up 3, so the vertex is going to be right here. We have a slope of negative 1 on one side, we have a slope of positive 1 on the other. We want to know when this blue graph intersects h of x. It never does. It appears to here, but there's an open circle. It appears to here, there's an open circle. They never intersect. There are no x values for which p of x equals h of x because the graphs of p and h never intersect. I'm just going to pull this picture down here so I can see this better. Identify the values of x for which h of x is less than 0. So h of x is this black one once again. It is not the blue one. It is less than 0 from negative 6 to negative 3.5 and from negative 2 to 1. I'm sorry, this says less than or equal to. So this negative 3.5 would be inclusive. It says equal to, so that includes where it is on the x-axis. And then it's going to include with that 2 inclusive to 1 inclusive, because it says equal to. Equal to, less than or equal to means on the x-axis or below it. For what value of x is p of x bigger than h of x? P of x is above from here all the way over to here, but we don't include this number because there's no x value for h of x. So we're going to go from negative 6, it's a closed dot, so it's inclusive, skips over negative 3, and then stops when it gets to 1, and it's a closed, no, it's an open. No, it's closed. It's closed because there is a closed dot here for h of x, and it's clearly above it there. For what values of x is h increasing? It's increasing as if you're going up from left to right. It's increasing from, but not including, -6 to -3. And it's increasing, but not including, 1 to 3. Whoops. Identify the values of x for which h of x is equal to 0. So where does it touch the x-axis? -3.5, -2. Identify the values of x for which h of x is greater than 0. When is it above the x-axis? It's above the x-axis from -3.5 to -2, and then from 1 to 5. And I need to clarify, although it is from -3.5 to -2, not inclusive, we are missing this point here at -3. So it's -3.5 to -3, skips over it, then goes from -3 to -2, and then goes from 1 to 5. Why is 5 included and nothing else is? 5 is included because we have a closed dot at the end of this interval. 1 is not included because it's an open circle. -3 is not included because it's an open circle. -2 is not included because it's on the x-axis, and this just says greater than. -3.5 is not included because it's on the x-axis, this says greater than. Identify the values of x for which h of x is less than 0. What's less than 0 from -6 included to -3.5 not included? And it's less than 0 after -2 till you get to 1. And then it's no longer below it anytime after that. I'm going to copy this graph again so I can see it down below. Identify the values of x for which h of x is greater than or equal to 0. Greater than or equal would be from here to here. It includes the endpoints, but doesn't include this -3. So let me write that down. That's -3.5 inclusive because that's on the x-axis. Skips over -3 because it's an open circle. Includes -2 because it's on the x-axis. And then it goes from 1 to 5, 1 not inclusive, 5 inclusive. One's not included because it's an open circle. 5's included because it's a closed circle. For what values of x is p of x less than h of x? When's the blue graph below? It's below from 1, just to the right of 1, until we get to 5. It includes 5. For what values of x is h decreasing? H is the black curve. It's decreasing from -3 to 1, not inclusive, and from 3 to 5. Increasing and decreasing intervals are never inclusive. Never. Increasing, decreasing, and horizontal intervals are never inclusive. That concludes the notes. Please do the homework assignment from section 1.4.